Okay, we're going to work on something called Descartes' rule of signs, and well, I think this is an interesting thing. I also think that it's a remnant from before people had calculators. In fact, solving polynomial equations was a huge deal back in the 17th century or 18th century when Descartes was around. So they were always looking for ways to do it better. And one he did was he figured out a way to figure out to know what kinds of zeros we should expect. Now this is I'm going to get a 0 on one side. This is a pretty simple cubic, and we've got a 0 on one side, and we have 2x to the third minus 4. So the idea here is that we look for sign changes, and we're looking for sign changes when it's in standard form between the terms. Since we only have two terms, and the first term is positive and the second term is negative, we have one sign change. All right? So what that means is that that tells us, when we look at the sign changes of the original equation, that tells us the number of positive roots we'll have. This kind of makes sense. If you look at this equation, if you were going to solve it, you'd add 4, divide by 2, take the cube root of a positive number. So you will have a positive, one positive root. We also look at the idea where, give myself a little space, where to find the negative roots, you do the same kind of analysis, only the first thing you do is you substitute a positive x for a negative x. So everywhere I have a positive x, I'm going to put in a negative x. Now when I put in a negative x and I cube it, I'm going to get a negative. So that's going to make that first term negative. When I look at my sign changes here, I do not have a sign change. So for the negative, I have 0 sign changes. Okay, my degree is 3. That means I should expect exactly 3 roots. Now, these roots could be positive or negative, or they could also be imaginary. So the total number of roots has to add up to 3. And my sign change is not giving me a whole lot of variability. You'll see in the next problem what I mean. So if I have 1 positive root, 0 negative roots, then the non-real root is going to be the leftover ones. So I have a total of 3 roots if I look at 1 positive, 0 negative, and then 2 non-real. Let's do the same thing with a more complicated equation. I can already tell I need more room. Okay, on this one we already have our 0 on one side. Let's look at the sign changes for the positive. There's one sign change, goes from negative to positive. There's a second sign change, and then I go from positive to negative. There's a third sign change. Okay, so if I'm looking at the positive roots, I have a possibility of 3. Now, our positive or negative or non-real roots can either be 3 or they could go down by 2. Okay, because our roots tend to go down, will always go down by 2. If you think of a non-real solution, let's look at x squared equals negative 25. If I square root that, I get x equals plus or minus the square root of negative 25. That means I have 2 non-real roots. So non-real roots always come in pairs. Our real roots can either come in pairs or they can go down by 2. So for our positive roots, we have 3 or down by an even number of roots of 1. Now we're going to do the same thing with our negative. I'm going to throw in a negative x everywhere I have a x. Now you'll find that the sign change was only going to happen for our odd, or we're only going to see the sign change from the original for our odd exponent roots. So again, x to the fifth, that's going to give me a negative x. So this will go to negative 2x to the fifth. X to the third will also give me a negative x, so that changes the sign of that term as well. And but when I square x squared, I get a positive. So that stays positive. Now we'll count up our possible negative number of roots. So we get one sign change there, and no sign change going from 6x to the third to 7x, but I get a second sign change going from positive to negative there. So my negative is going to be either 2 or 0. So what we do is we make combinations of these possibilities in order to see how many non-real we're going to have. I'll show you what I mean. So I'm going to just do a little bit of work here. All right, so for my positive roots, I can either have a 1 or a 3. And for my negative roots, I can either have a 0 or a 2. And for my non-real roots, it's going to be whatever is left over. So if my positive root is 1, then my negative root can either be 0 or 2. When I add those up in the first column, I get 1 plus 0. I know I will have 5 roots because it's a 5th degree equation. So 1 plus 0 gives me 1. If that's the case, if I get 1 positive root, 0 negative roots, then that means I have to have 4 non-real roots to add up to 5. All right, looking at the next variation, if my positive root is 1 and my negative root is 2, that adds up to 3. That means my non-real is going to be 2. So all of these columns have to add up to 5. But I'm going back to the positive because I just tried all the possibilities. If our positive roots are 1, let's take a look at the positive roots being 3. If I have 3 positive roots and 0 negative roots, 3 plus 0 is 3, I will definitely have 2 non-real roots to make up to the 5 expected roots. If I have 3 positive roots and 2 negative roots, that adds up to 5, and I'm not going to have any non-real roots. And I think that is all the possibilities. So for my non-real, I can either have 0 or 2 or 4. And you'll see those options when you do the problems on the homework site. Okay, I'm going to stop this video and I'll see you on the next one.